Okay, so I'm doing this one here, poisoning by gradients. So we're going to use the SecML library again, which has these security-oriented functions. I've already installed that here. So now we're going to generate another data set with two blobs of data, Gaussian distributed, just so we can practice isolating them. We're going to have 100 training set sample, 100 validation sets, and 100 in the test set. So it's going to make them here with the centers at -1, and 1, 1, and a standard deviation of 0.9. So they should overlap, but not too much. And I'll draw a picture of them. There we are. So they got red dots and blue dots. And the goal is to make a machine learning model that can discriminate between them. So we make a standard machine learning model, as we've done many times before. And it's going to train it. And there it's done, and it's good. It's 94% accurate at separating them. And we can visualize the border here. And there you see, it's made this curvy border. This side is blue, that side is red. And as you can see, there's 6 instances that are wrong, and that's why it's 94% correct out of 100 dots. So that makes sense. And now we're going to visualize, we're going to perform a poisoning attack on this by using this CAttack poisoning function. And as before, this is going to carefully figure out how to modify this data, not to evade it like we did last time, but to poison the training data. So this evasion attack is where you create an instance for it to measure, and it confuses the model that has already been trained so that it doesn't correctly classify it. But a poisoning attack is where you make a different poisoning data set, which when you train the model on the poisoned data, it learns bad habits. So this should show a sort of heat graph showing you how much different areas are contributing to the model. That's the plan here. And so it moved, we chose, okay. So it's going to move the first point from the star to the diamond above it. It has, now what I did was I told it which point to use to poison it. We're going to move a single point to poison the data. And somewhere I told it which point to use, which I think was point number 10. Yeah, this is number of poisoning points, 1 poisoning point. And here it is, use point number 0, the first point. So it moved point number 0 from the star to the diamond. And the star is here and the diamond is up there, hard to see. So by moving this 1 point from here to there, it's going to have the most effect on the training weights and cause the model to learn bad habits. So now we're going to train the model on the poisoned data and see how much it harms its accuracy. It was 94% accurate before poisoning. And after poisoning, it falls down to 93%. So moving just 1 dot out of 100 had a small effect on it. All right, and now you can visualize the poisoning process. See how this looks. This, I think, is going to show the boundaries before and after poisoning. There you are. So the original classifiers here and the poison classifiers there. And as you can see, it took one of these points, moved it up here, and changed it to blue. So now the poisoned model has a significant change to try to capture that point. And that's the 94% and the 93%. And this is on the training set, and this is on the test set. And you can see since this dot was up there, it learned to put the border up there, and that meant it hit this dot here in the test set, which is why it had a lower percentage. This 1 dot was now misclassified, which caused the accuracy to fall by 1%. All right. So there's now if you poison more points, like 10 points, then you'll see it has a larger effect, changing the, this is going to poison the first 20 dots. And that's going to lower the accuracy by quite a bit. You can see it's making a lot more mistakes. And then you can poison all the points, which will really confuse it. And then you can play with the random seed to poison different dots and so on. There's various examples of poisoning attacks here. And these are, before we had one where we just took the labeled digits and changed the labels of some of the digits, but here you do a carefully calculated change to have the most effect. All right, so let me stop this recording.